Our solar system, a grand cosmic clockwork, often operates with a predictable, almost serene rhythm. Planets trace their ancient orbits, and distant stars twinkle with unwavering consistency. But every so often, this celestial tranquility is shattered by events so sudden and spectacular they command our immediate attention. And just in the past few days, we've witnessed precisely such a disruption. The protagonist of our story is a visitor from the frigid outer reaches of our system, Comet C 2025 R2, more commonly known as SWAN. This icy wanderer, discovered by the Solar Wind Anisotropies instrument aboard the SOHO spacecraft, was on a fairly unremarkable journey. That is, until it wasn't. Quite unexpectedly, SWAN experienced a dramatic outburst, its brightness surging by an astonishing factor of 16. For astronomers, this was a startling development, a sudden flare-up that transformed the comet from a faint smudge into a prominent feature in the night sky. As if this cosmic spectacle weren't enough, another, far more powerful event was unfolding just 93 million miles away. Our own star, the Sun, roared to life. It unleashed an M6.4 class solar flare, its most powerful eruption in many months. This wasn't just a flash of light, it was a colossal explosion of energy. From the flare's epicenter, the Sun blasted a gargantuan cloud of charged particles and magnetic fields into space, a phenomenon we call a coronal mass ejection, or CME, a billion-ton wave of solar material hurtling outwards through the system. Here is where the plot thickens. The comet's sudden brightening and the Sun's violent eruption occurred almost simultaneously. A remarkable coincidence, one might say. Two independent dramatic events happening in the same cosmic neighborhood at the same time. But in astronomy, as in any science, we must question everything. Could this be more than mere chance? Is it possible that the Sun's powerful outburst directly triggered the dramatic transformation of Comet SWAN? This is the tantalizing question that has astronomers and space enthusiasts buzzing. We are faced with a celestial mystery, a case of cosmic cause and effect, or simply a grand, beautiful coincidence. In the early months of this year, a new celestial wanderer was unveiled to humanity. Detected by the keen eye of the Solar Wind Anisotropies instrument, or SWAN, aboard the SOHO spacecraft, this icy visitor was christened Comet SWAN. From a faint smudge on a digital sensor, it has rapidly blossomed into one of the most eagerly anticipated and closely watched comets of the decade, a true cosmic celebrity in the making. As Comet SWAN ventures deeper into the heart of our solar system, its transformation has been nothing short of spectacular. The Sun's relentless energy is waking the ancient ice within its core, causing it to shed gas and dust at an astonishing rate. Astronomers, both professional and amateur, have reported a dramatic surge in its luminosity. What was once the preserve of powerful telescopes may soon become a prize for anyone with a humble pair of binoculars. A faint, ethereal smudge against the velvet black of the night sky, a ghostly visitor from the dawn of time. The climax of this celestial performance is set for the 21st of October, 2025. On this date, the comet will grace our skies at its nearest point to our planet. While the term close approach might sound alarming, rest assured it will pass at a perfectly safe distance of many millions of kilometers. Yet, this proximity offers a golden opportunity. For scientists, it's a chance to study a primordial relic from the formation of the solar system with unprecedented clarity. For the rest of us, it promises a potentially unforgettable celestial spectacle, a rare and beautiful reminder of the dynamic universe we inhabit. The dramatic brightening and the beautiful tale we admire are born from a violent, chaotic process. Outbursts, like the one we just witnessed, are a hallmark of cometary behavior. Think of the comet's nucleus as a dirty snowball, a loose collection of ice, rock, and dust that has journeyed for millennia from the frigid outer reaches of the solar system. As it nears the Sun, this frozen heart begins to warm. The ice doesn't melt, it sublimates, turning directly into gas. This explosive release of gas and trapped dust creates the glowing atmosphere, or coma, around the nucleus. This material is then swept back by solar wind and radiation pressure to form its magnificent tails, making every comet a unique and fleeting masterpiece painted across the cosmos. Almost immediately after SWAN's outburst, the Sun fired off a strong M6.4 class solar flare. It also launched a coronal mass ejection, CME, a huge bubble of plasma and magnetic field. Solar activity like this is expected because the Sun is approaching its solar maximum, the peak of its 11-year activity cycle. These flares can affect satellites, communications, and sometimes even power grids on Earth. In the vast theater of the cosmos, coincidences can be breathtaking. As Comet SWAN, a visitor from the icy depths of space, made its perilous journey towards the Sun, it suddenly flared up. This cometary outburst, a dramatic release of gas and dust, painted a spectacular tale across the void. But almost simultaneously, the Sun itself put on a show. A colossal coronal mass ejection, a billion-ton cloud of solar plasma, erupted from its surface. Some observers couldn't help but point to the uncanny timing, a cometary outburst, then a solar blast. The proximity of these two events immediately sparked a tantalizing question that echoed through online astronomy forums. Could the comet, this relatively minuscule celestial wanderer, have somehow triggered the Sun? Was it possible that its passage through the Sun's extended atmosphere, or its interaction with the solar magnetic field, had been the proverbial straw that broke the camel's back, provoking our star into a violent outburst? The idea is certainly romantic, a David and Goliath story on a cosmic scale. However, mainstream science offers a firm rebuttal. No. A comet is far too small and distant to affect solar physics in this way. To put it into perspective, the mass of a comet is like a single grain of sand compared to the mountainous mass of the Sun. The energy driving solar flares and CMEs originates deep within the Sun, governed by magnetic forces of unimaginable power. The influence of a passing comet on these titanic processes is, by every known physical law, utterly negligible. And yet, the mystery of the timing lingers. If the comet didn't cause the solar blast, what explains the coincidence? This raises a more profound question. Are we simply witnessing a random overlap? Or could it be that both the comet and the Sun were reacting to larger space weather conditions we don't fully understand yet? Perhaps a shift in the interplanetary magnetic field influenced both bodies at once. This suggests we are observing the intricate, interconnected workings of the solar system's weather, a complex system we are only just beginning to comprehend. Some researchers speculate about cosmic chain reactions, where radiation, plasma, and dust interact in ways we can't yet explain. Others dismiss this as pure chance, a comet outburst and a solar flare happening independently. Either way, the timing has fueled online discussions about whether our solar system is entering a particularly volatile phase. Comet SWAN is still racing toward its closest approach, and the Sun's activity will only get more intense in the coming months. Are we witnessing nothing more than a coincidence? Or are these events a sign that space weather is more interconnected than we think? Stay tuned, because the story of Comet SWAN has only just begun.